Let's write a program to solve the system of linear equations using matrices. In addition to that, we will be doing addition, subtraction and product of matrices. So what is a matrix? Matrix is rectangular array of numbers. By that I mean rows and columns are the building blocks of the matrix. For example, in this matrix A, we have 2 rows and 2 columns. Row is a horizontal array of numbers and column is vertical array of numbers. So the first row here consists the elements 3 and 1 and the second row consists 4, 5. If we want to take the element out of the matrix, we have to specify its position in that matrix, that is its row index and the column index. For example, if we want to take 3 out of this matrix A, we have to specify which row it is and which column it belongs to. 3 belongs to first row and first column, so we write A11. Similarly, if we want to take 4 out of this matrix, we have to specify its row, which is second row, and its column, which is first. So A21 is 4. This is nice and clean here, but what if you want to write this in a programming language? By the way, I am using JavaScript. You can use any other language. It is just same in all languages, just the syntax changes. We use double arrays, arrays inside arrays. We initially take the big array and push smaller arrays inside it, which are rows of a matrix. So this array consists of 2 more arrays, which are rows of the matrix A. 3, 1 is the first row, 4, 5 is the second row. If we want to get element out of this array, we have to specify its row first and then its position in that row. For example, if you take 3, its row is first row, which is 0 in arrays, because arrays count from 0. Always remember that. And array of 0, we will get the first row. In that first row, its position is 0. So array of 0, 0 is 3. Similarly, if you want to take 4 out of this array, you have to specify its row, which is first row here. I mean 0, 1, which is second row, second count, but in arrays it is 1. Array of 1 and its position is 0. Array of 1, 0 is 4. Now let's write the code. Create class for the matrix. Constructor will take the data, which is of course the double array we given as a matrix. So this data is equals to data. Let's make a new matrix, new object out of the class. Let mat equals to new matrix. I am giving 1, 2 as first row and 3, 5 as the second row. If you take a quick look in the console, you can see rows stored nicely in arrays. Now let's write few helper methods which help us a lot for this matrix class. The first few are get row, get column. Get row, as the name suggests, it returns the row we need. Suppose we say get row of 0, it returns the first row. Here is 1, 2 as an array. If we say get row of 1, it returns the second row. So what it literally doing is return the this.data of whatever row we want. Remember, this.data stores the rows in a array, so we just return this.data of n. Get column is little bit tricky one, because we have to loop through each row and get nth position, which is the column position of the element. Suppose we want the first column, we loop through each row and we take first element in each row. If we want third column, we loop through each row and we take third element in each row. That results in a column, third column. So let's make an array to store all those elements we get looping through each row. Let's name it column, and we fill up the column by looping through each row, and this data of I is row. After that, we specify the n, which is the column number, and by the end we return column, which is array. Not so tricky. If you get the idea, it is most basic one to start with. So mat.getColumn of 0, we get 1, 3, which is indeed first column of our matrix. I am so sick of looking at these arrays in console, because I have to open them every time I have to look them. So let's write a method print, which prints our array to the document HTML. I created a paragraph tag, and these matrices, these arrays will just push into that. So we loop through the matrix and get each row, and we loop through again that row to get each element. Actually, this is first step, the first exercise to print each element onto the console or document HTML, whatever. So to get rows, we loop through these dot data, and to get element, we loop through the data of I. By the end, this dot data of I is row, this dot data of I of j is each element. Once it print a row, I add a breakpoint. That means the new row will print below the first row, not side to it, side by side, not side by side but below. So if j reaches its last element in a row, we add a break, a BR in HTML. So if j equals to this dot data of 0 dot length minus 1, we say p dot inner HTML plus equals to PR in tags. And now let's try to print our matrix to the document. We say mat.print. Well, that's great. That's far more better than looking at these arrays in this console. Let's create another matrix, which is mat2. Let's give it some data. This is going to be 3 by 3 matrix. So we can print these two by saying mat2.print. Let's say mat2.print. Just look at the result. Yeah, there we go. Because the second matrix, I literally created a dash function to create a dash between them. So let's call the dash function in between two of them. There you go, our beautiful dash. Now we are ready to go. Let's get rid of this matrix 2. So what do we do now? Let's actually get rid of the matrix 1 as well. Let's actually create a method called empty, which creates 0 matrix with specified row count and column count. For example, if we say matrix.empty 2 2, it will create a matrix with 2 rows and two elements in each row as 0 0. So we get 0 0 in first row and 0 0 in second row. Similarly, if we say matrix.empty empty, not empty, empty 3 3, we get 3 rows and 3 elements in each row, which all are zeros. By end of this method, we want to return a matrix with all of its elements as zeros with the given row count and column count. So first we need to create rows, and then we have to fill up those rows, and that's our data, and we put the data in return new matrix of data. Its data BR is an array, and we have to push that array with inner rows, which are rows which have column amount of elements, which are all zeros, of course. So we need 2 loops. First loop go from 0 to R, and the second loop go from 0 to C. In the second loop, we create an array and fill up with zeros and push it to the R, and we return new matrix with these data. Hope you get this. Take a moment, it is easy. Oops, we used the R variable twice. Let's change its name to res, which is shorthand for result. Yet we don't see the output. That's because it is a static method, but I call it with a new keyword. So let's get rid of the new keyword. We can call this as matrix.empty 33 or 44, whatever the dimensions, .print. So this is what I mean 0 matrix. I have given 4 4 as dimensions, so it created 4 arrays, and each array 4 elements of zeros. This is quite useful later on, you will see. Now let's create our add method, which adds up a matrix to itself. Let's take a matrix. Adding a matrix is pretty much straightforward. We take each element of the first matrix and add up to each element on the second matrix of same positions. So we take A00, add up with B00. We take A01, add up with B01, which is pretty much straightforward. We can achieve this by using 2 for loops, one going through rows and the other going through each element. For adding, the both matrices have to be in same dimensions, right? As you can see, I already started using the empty. The resultant matrix will be also in same dimensions. So first I create the result as empty matrix, which is zeros, and fill up the matrix and finally return the matrix. So result is a final matrix which I am going to return at the end. Result dot data of ij will be equal to these dot data of ij plus mat dot data of ij, which is saying add those both elements at same positions. Let's test this now. Let mat A is equals to new matrix. Mat B will be also a new matrix of same dimensions as matrix A. So matrix A consists of two rows, which are 1, 2 as first row and 3, 5 as second row. Matrix B also consists of two rows. Now we can say mat A dot print, and with the dash you can say mat B dot print. We print those two matrices, and with the dash we add up the matrix A and matrix B and also print that. Remember, the returning is also a matrix. We get the error because I say not in the print method but in the add method. I forgot mat or data. Remember, the data consists actual arrays, not the mat itself. Mat is object. Yeah, we get the addition done. 1 plus 5 is 6, 2 plus 5 is 7, 3 minus 2 is 1, and 5 plus 3 is 8. Yeah, it's working. We can just copy paste the add method and change the symbol from plus to minus. We get the subtract method. Change the symbol and subtract method is ready. Let's try it. You can see 1 minus 5 is minus 4, 2 minus 5 is minus 3. It's working. Why not? It will work. Now let's create few more helper methods which help us in this long journey of multiplication, finding determinants, and so on. So insert row, it do what it exactly sound like. It insert a row on given position. It just replaces the row. So this dot data of n, that is row, and it replaces with the given row. Insert column, you get it. We loop through each row and we get the element of the column which is given. So insert column of 1, we loop through each row, we replace each row first element. This is this data of I of n, replace it with our data. Let's try it now. Let's get rid of matrix B. Matrix A dot insert row. Let's insert n in the first row. We get some problem here. Let's fix it now. Because we have to give the input as a matrix, not a element, not a single quotes. You can see the first row is replaced with n's. Let's replace column. Great. This replace row and columns are working as well. Let's create two more siblings for the insert row and insert column, which are fill row and fill column. Insert row take array and replace it with our array, which is row or column, whatever. But in fill row, it takes a value and replace the entire row with the same value. So fill row, we specify which row we have to fill, and we loop through that row, change each element to the value. Same for the fill column as well. We loop through each row, we get each element that belongs to that column, and we replace it with our value. Let's see our field row and field column are working or not. You can see the column is replaced with n's. That's great. So what's next? Here, the mighty matrix multiplication of m1 and m2. Let's make it as a static method, so we can multiply two matrices by saying matrix dot mult m1 and m2. So how do we do matrix multiplication? The way we multiply matrices are by taking each row in first matrix and multiplying the each row with each column of the second matrix. For example, if you take the first row, first matrix, which is 1 4, and multiply it with first column in the second matrix, which is minus 2 4. 1 times minus 2 is minus 2 and 4 times 4 is 16. We just add them up. Oops. Yeah, 4 times 4 is 16. And we take the same row and multiply it with the second column of the second matrix. So 1 times negative 3 is negative 3, 4 times 1 is 4, which is plus 4, of course. We are done with first row, and then we take second row and repeat the process. We take second row and we multiply it with first column of second matrix, which is 3 5 times negative 2 and 4. 3 times negative 2, which gives us negative 6, and 5 times 4, which gives us 20. Negative 6 and plus 20. And with the same row we multiply with second column of second matrix. So basically what we're doing is taking each row in first matrix and multiplying with each column in the second matrix and adding up the result, putting it to a final matrix, which is our result. Let's take this example. Just by looking at this, we can see the dimensions of the resultant matrix. What we are doing is we multiply each row and each column, each row and each column. So what do we get? The resultant matrix rows will be the number of columns of the second matrix, and the resultant matrix columns will be number of rows of the first matrix. Remember that if you multiply two matrices, the resultant matrix dimensions, the resultant matrix rows will be number of columns of second matrix. The resultant matrix columns will be number of rows of first matrix. And our multiplication is as usual. We take first row and we multiply with the first column. 1 times 1 is 1, negative 4 times 2 is negative 8, 1 times negative 4 is negative 4. You get the idea. And we take the same row, multiply it with the second column of second matrix. So 1 times 3 is 3, negative 4 times 6 is negative 24, 1 times 5 is 5. We are done with the first row and we go to the second row. Same process, we take the second row and we multiply it with each column, and we take the third row, we multiply it with each column. So let's take second row. Second row times first column of second matrix. 2 times 1 is 2, 1 times 2 is 2, 3 times negative 4 is negative 12. Oh, that's 2. Don't get confused. Sorry for this writing. I don't have any pencil. I just writing with my finger on laptop touchpad. So yeah, that's the way I write. You can understand, I think. So we multiply the row with the second column of second matrix. 2 times 3 is 6, 1 times 6 is 6, and 3 times 5 is 15. You can guess the final answer, final row of the final array, final matrix. We take the last row and multiply it with first column. 3 times 1 is 3, 2 times 2 is 4, 5 times negative 4 is negative 20. And we take the row and we multiply it with the second column of second matrix. which gives us 3 times 3 is 9, 2 times 6 is 12. Yeah, we put the arrow first and then we do multiply. 3 times 3 is 9, 6 times 2 is 12, 5 times 5 is 25. Just add them up, we will have the final matrix. Let's code this up. As you saw before, we did a lot of row column multiplications. So let's write a method which did row column multiplication and give us a scalar value. Multiply row column, which take a row and column. It is very easy. We write one for loop through the row and column because the both are same dimensions, so we don't have to worry about anything. We just say row of I times column of I. We store that in a sum variable and return the sum by the end. So let sum equals to 0, sum plus equals to row of I times column of I. So what do we do in the multiplication? We take each row in the first column. So we can write a for loop to take each row in the first column, first matrix. At first, let's try our multiply row column function, method is working or not. Let's give the first row 1, 2 and first column 3, 4, 11, which is right. 1 times 3 is 3, 4 times 2 is 12. 8 plus 3 is 11, not 12, sorry. So we write a for loop to get each row of first matrix. So for let I equals to 0, I less than m1 dot data dot length, which contains rows, and I plus plus. And for each row, we multiply it with each column of the second matrix. So we need a other loop which loops through each column of the second matrix. So for let j equals to 0, j less than matrix is 2 dot data of 0 dot length. Data of length is rows, data of 0 dot length is columns. Let's create our result matrix. We create it with as empty. We know its dimensions 2. I told earlier the dimensions, the row dimensions are number of columns of the second matrix and the column dimensions are number of rows of the first matrix. So we just put that there. Initially we make all zeros, we fill up those zeros in these for loops and we return the matrix by the end. Okay. Now we have each row and each column. What do? We fill up result of ij equals to, we matrix dot multiply row column. We do multiply the row and column. The row is straightforward. These dot data of m1 dot data of I, which is row of first matrix. In the column, we have a helper function, get column. So we do m2 dot get column j. We multiply that and put the data into result matrix. We return the result matrix. That's it. That's our matrix multiplication. We get the error because result, we have to put result of data, not result of ij. Result of data of ij, because result is a object, result of data is array. Let's test this. Let matrix A is a matrix and matrix B is also a matrix. 3, 4 and -2, 1. We print the first matrix, we print the second matrix, we put a dash between them and we multiply matrix A and matrix B, we print that as well. As I told you, we get the error because we have to put dot data, right? Yeah. there we go. Let's take a quick look. First row is 1 2, first column is 3 minus 2. 1 times 3 is 3, 2 times 4, 2 times negative 2 is negative 4, 3 plus negative 4 is negative 1, which is the first element result matrix. Great. Let's take first second column. 1 times 4 is 4, 2 times 1 is 1, 4 plus 2, 2 times 1 is 2, 4 plus 2 is 6. Great. So our matrix multiplication is done. So, if you made up to this point, a great clap, a pat for you. You did a great job. Now, the main part comes here, the determinant, the deadly determinant. Let's see how we find the determinant. From here on, you might see a change in my voice because last time I recorded on an empty room. So, how do you find the determinant of a 2 by 2 matrix? 2 by 2 matrix is the simplest case we can find the determinant of. So we take a cross multiplication like thing. We take 2 times its cross, which is positive 4, and we have to take the alternative symbols here for element to element. So 2 is positive and 1 is negative. Positive, negative, like that. So negative 1 times 3 is 3, negative 3. 4 times 2 is 8, 8 minus 3 is 5. So for the second matrix, we do the same. We take negative 1 times 4, which is negative 4. And we take 5 times 7, which is 35. But we have to take alternate symbol, so negative 35. Negative 35 and negative 4 is negative 39. So you have to be careful with these negative symbols. They come positive, negative. If you have 2 more elements, like it's a 4 by 4 matrix, we take positive, negative again. You get the idea, right?
Now let's try to find the determinant of a 3 by 3 matrix or any matrix that is greater than 2 by 2 matrix. Initially, we will take the first row as reference row, and we take each element in the first row and remove the corresponding row and column which the element belongs. For example, we have to take the first element, which is 1 in the row, and then we remove the row and the column the 1 belongs to. Right? We just remove it, and then we get a 2 by 2 matrix. After removing the row and column, we find the determinant just like we find the determinant for a 2 by 2 matrix, and then multiply it with 1.
And we have to give alternative symbols to the elements we take starting from the place. So the next element is minus 1, and we have to give the minus symbol to the minus 1, which is plus 1. So minus of minus 1 plus 1 times, and then we remove the row and the column the minus 1 belongs, which is first row and second column. We remove it and we get a 2 by 2 matrix. So we find the determinant of the remaining 2 by 2 matrix and multiply it with it. You get the idea, right? Let me show you for the minus 1. We just remove the column and we just remove the row. So we get a 2 by 2 matrix, which is 3 minus 2, 2, 1. And finally, we take the last element and remove the row and column it belongs and find the determinant of the remaining 2 by 2 matrix and multiply with the element. Right, 2 times the remaining matrix is 3, 4, 2, 5. So now let's find the determinant of this matrix. So 1 times the determinant of 4, negative 2, 5, 1. 4 times 1 is 4, and 5 times negative 2 is negative 10. Negative of negative 10 is positive 10. So, and there we get an alternative symbol for this minus 1, so which becomes plus 1 times the remaining determinant. 3 times 1 is 3, and 2 times negative 2 is negative 4, and we have to subtract it, so it becomes positive 4. And the last element, 2 times the remaining 2 by 2 matrix. 5 times 3 is 15, and 4 times 2 is 8. 15 minus 8. So 1 times 14 plus 1 times 7 plus 2 times 7 is 14. Actually, I forgot the 2, so the answer should be 35. 14 plus 7 plus 14.
Now let's find the determinant of this matrix. The initial step is to take the alternative symbols for each element of the reference row. These three matrices are the same. I just drew them 3 times to show each step separately. So we take the first element and remove the row and column it belongs. So 1 times the determinant of the remaining 2 by 2 matrix. This is a quick review for another problem. You can skip this if you understand the logic behind finding the determinant. So, and we take the second element, which is positive 1, but we have to take the negative symbol, minus 1 times the determinant of the remaining 2 by 2 matrix. After removing the row and column it belongs. So determinant of 2, 4, 3, 5, minus 1 times 2, 4, 3 and 5. And finally we take the last element, which is negative 3. So negative 3, and we remove the row and column it belongs. Negative 3 times the determinant of 2, 5, 3, 2. 2, 5, 3, 2. This calculation is quite simple. Now let's jump into code. So we have a method get, and we take a matrix. So we have to take the first row and loop through it for each element. So for let I equals to 0, I less than m1.data of 0. m1.data contains all rows, so of 0 means the first row. And we loop through it, we take the element which is the first element. So 0 of 0, 0 of I should be the element since we are looping it. So element equals to m1.data of 0 of I. And we have to remove the row and column, and we will get a 2 by 2 matrix, or if it is a 4 by 4 matrix, if we remove the row and column we will get a 3 by 3 matrix. So we need a matrix to store the removed matrix, removed column, row column matrix. So removed RC mat equals to matrix. First we initially copy the matrix. We have to remove a row and column, so the row count and the column count will be reduced by 1 each. The copying should be very familiar to you by now, since we just loop through rows and columns and get each data from the first matrix, the matrix which is in the argument, and give the data to the result matrix which we return by the end. So we loop through rows, and for each row we loop through elements. We give the elements data to the result and return the result matrix. Now let's try if this copy is working or not. Let b equals to matrix.copy mat a, and we print the b. So we should get 2 identical matrices on the screen, which we get. Since it's working, let's continue our dead code. Once we copy the matrix, we can manipulate it. The manipulation here needs to be deleted the row and column. So we just fill the first row with the keyword del, which means every time we take an element, the first row will be always deleted and the column of the element also deleted. So fill column I of del. Let's take a look at the matrix. It is a static method, so matrix.get mat a. As you can see here, when you take the first element, it just fills the first row and the first column with the keyword del, and we take the second element, it fills the second column and the first row with the del, and so on. Since now we have a matrix that is filled with the keywords del, we need a new matrix which should be generated from these matrix, and it shouldn't have the keyword del. Let's make a new method to prepare a matrix for us, removing these del keywords. So let new matrix equals to matrix dot matrix from del. We pass the matrix which has del keywords. So what do we do now? We just look through the matrix and we check if the element is the del keyword or not. If it is not a del keyword, push the number to the new matrix and return the matrix by the end. So let result equals to matrix.empty. The size of this result matrix should be one less than the row and the column of the matrix we are giving, since we are removing a row and a column, right? So we look through each row and each column of this argument matrix and we check if the element is del or not. So if the mat dot data of ij is equals to del, if it is equals to del, what do? We need two more variables to store our new elements in our new matrix, because we have been using the ij for our old matrix, right? Data of ij, but we need a new two variables to store our new elements in this matrix, that is iijj. Let's call them iijj. Don't get confused. iijj are just the positions for our new elements after checking if the element is del or not. So if the element is not del, then rest of data of iijj equals to mat.data of ij. When the column should increase, when the column should increase if the del is not equals, if the element is not equals to del. And if we reach the end of the column of the argument matrix, we just increase the I and make the j 0 again. Let's see if it is working or not. Just don't get confused. The jj is simply the column position of our new element. We get an error of yes, we forgot to return our result matrix. So we will return the matrix, return res. The result is not favorable. We must made a mistake. Let's see what it is. Well, yeah, the initialization of iijj should be outside the for loop, right? Now what's happening is, for every time the row changes, the iijj becoming 0. Here is the result. When the element is 1, we get the remaining 2 by 2 matrix, and the element is 2, we get the remaining 2 by 2 matrix, and so on. So now we have the matrix, now we have the remaining matrix, and we have the element, and the determinant is quite simple to calculate now. So determinant equals to new mat determinant. Here you can see this is a recursive function, right? We're calling the same function inside the same function. This, it is sure a recursive call. So the recursive call will go on until it hit a 2 by 2 matrix, and it is the base case. We will write the base case in the beginning. The sum should be simply element times the det, the remaining det of the remaining matrix. Since it's a recursive function, we need a base case to stop the recursive function at some point. So the sum point should be the determinant of a 2 by 2 matrix, which is the simplest case. So if the data dot length is 2, which is a 2 by 2 matrix, we just multiply the elements cross linkingly. So m1 dot data of 0 0 times m1 dot data of 1 1 minus m1 dot data of 1 0, right? 0 1 times m1 dot data of 1 0. Yep. And the another base case for this function is when the data dot length is 1. So if it is just one element, the determinant is just the element. But since we haven't considered the alternative symbols yet, we have to give alternative symbols for each element. So every time we loop through, we check if it is a even number, and if it is a even number, the sign is -1, else the sign is +1, right? For even numbers it is -1. We start the sign with +1 and we multiply with the sum with the sign. Let's see if this is working or not. So let determinant equals to matrix dot det, matrix dot det of the new matrix. Yep, we have to pass the matrix. We get the determinant 9, which is, I think, not correct. Let's check if the answer is correct or not. One, two, three, 3, 4, 5, and -2, -4, -2, +3. Calculate the determinant, and the determinant is -9. Of course, the elements in the array starts from 0. So yeah, even number should be positive and the odd number should be negative, and we get the determinant -9. And now finally we have all the weapons to find the solution of system of linear equations. We can use Gramos method now, which is quite easy method among other methods to find the solutions. Let's say we have the system of equations in two variables. The first equation is 2x plus 3y is 10, and let's comment this out. The second equation is, let's say, 3x plus 6y is 15. Let's say we have these two equations which will create a 2 by 2 matrices for each of them. The first thing we have to do is take the coefficient matrix. We have to take the coefficient matrix. So the coefficient matrix is equals to, the first row is 2, 3, and the second row is 3, 6. Okay, we store the coefficient matrix and we store the solution matrix. So the solution matrix is simply a vector. So the solution matrix, or we can say it as right hand side matrix, which is simply a vector 10 and 15. But we have to consider it as a matrix, right? It should be the first row first element and the second row first element. So the formula here is coefficient matrix times the unknown variables is equals to right hand side matrix or solution matrix. And the variable matrix contains our unknown variables such as x, y, z, any unknown variables in our equations. In this case, simply x and y. So this is the structure of our two variables in our code: a variable matrix, a coefficient matrix, and a right hand side matrix. And we find the determinant of the coefficient matrix, and let's call it del. Del equals to matrix dot det of coefficient matrix. And we replace the first column of the coefficient matrix with the right hand side matrix and find the determinant, which we will call del x. So del x will be simply the determinant of the coefficient matrix, but the first column is replaced by right hand side matrix. After replacing the first column, we will get 10 instead of 2 and 15 instead of 3. That is del x. Of course, the determinant of this replaced column. And simply del y, which will be a replacement of the second column. So we get 10 instead of 3 and 15 instead of 6. And find the det. Those are the del x and del y. And the unknown variables are simply x equals to del by del x and y equals to del by del y. Quite simple, right? Now let's convert this algorithm into code. As we've seen earlier, we need three matrices to store our coefficients and unknown variables and the right hand side solutions. Not really solutions, they are simply right hand side. X equals to 2, y equals to 3, x plus y is 5, which is 2 plus 3 is of course 5, 2x plus y, 4 plus 7 is 7. So 4 plus 3 is 7. The coefficient matrix here is a new matrix. We give the data 1 1 and the second row is 2 1 1 1 are the coefficients of the first equation and 2 1 are the coefficients of the second equation. That is our coefficient matrix. And we need a variable matrix. Here the unknown variables are x and y, so it will be a new matrix. Give the data, it will be simply x and y in strings, and the final matrix is the RHS matrix, right hand side matrix, which will be a new matrix, and the data of this matrix is the right hand side of those two equations, which is 5 and 7. Of course the 3 is a typo. The 5 and 7 are only two elements of the right hand side matrix, and we will create a new method to solve these three to solve the equation with these given three matrices: coefficient, RHS and variables. We pass the three matrices to this method and it should return the solution for this matrix. Let's create the method. And we will be using the insert column to insert our RHS matrix in the place of the first column to find the del x, right? So static solve, which will take three matrices: coefficient matrix, RHS matrix and variable matrix. And the del will be simply the determinant of the coefficient matrix, and we need del x, del y, and if it is a three system of equations, we need del z. For n system of equations, we need del n's. So let's make an array to store all those del x's. So del x is an array, and we loop through each column of the first row and replace each column with our RHS, and we will be using insert column after we copy the matrix to make sure not change the original matrix, and we insert the column at every column of the element, and then we replace it with RHS. Let's print it. Something is wrong. Let's check why it's not working. Of course there's a typo here, and we have to consider the variable matrix as well as the RHS matrix not just as vector but as a matrix with a row and a column. So 3 is in the first row, first element, and 5 is in the first row, second row, first element. Same for the variables. We got two matrices, each replaced by the RHS matrix with the corresponding column. So now we simply store the determinant of these new matrices inside the del x array. So del x dot push matrix dot determinant of this copy, and we need a result, which is simply the solutions, the unknown variables, the result, the integers of the unknown variables. Rest dot push del x divided by del, and return a new matrix with the data as result. Let's run this. Since it returns a matrix, we can directly print it.
we get 2 and none. Let's see where the error. Let's check the del x array. Okay, it is an array, so we are directly dividing the array with del. We have to divide the array of I with del, then we get 2 1, which is not the solution. Yes, let's change this error for 7. The solution will be 2 and 3 as expected. Now let's try system of 3 equations. Let's see if it is still working. Let's take x equals to 1, y equals to 1, and z equals to 2. X plus y plus z equals to 4, and x minus y plus 3z is 6. 2x plus 3y plus z equals to, what is the value? 2 times 1 2, 3 times 1 3, 2 plus 3 5, 5 plus 2 7. Let's change the coefficient matrix according to our new equations. We need a new variable z, and the RHS matrix is 4 5 6. We got a none. Let's see why. The reason behind this is the Gramos method does not work if the determinant of the matrix is 0, right? If the determinant is 0, we are simply dividing the del x values with the 0, which is not a number, like that's literally none, right? And none. So the determinant is 0. We can't simply find the solutions of this matrix with this method. So if del equals to 0, it is written, or we say cannot be solved, like something like that. So make sure the determinant should not be equals to 0. And if any other equations which the determinant not equal to 0, this will find the solutions. Let's change the equation. So here are the solutions: 1 1 2. And all that remaining is a nicer way to give these coefficient matrix and the RHS matrix by the user. I will leave it to you, or you can simply watch me writing that. If you want, just comment it. So you can see cannot be solved because the determinant is 0. The only thing remain is a simple interface to give the input equations. So here is my simple dirty interface.